In the last lesson, we covered the basics of MySQL. In this lesson, let's take that knowledge and apply it to PHP. We're going to connect database to PHP, run queries using PDO. You will learn about prepared statements, SQL injection, and so on. There are a few ways you can add database usage to your PHP application. One is by using native PHP functions for MySQL driver, for example, using MySQLite_functions. Another way is by using the PHP Data Objects, or in short, PDO. Both PDO and MySQLite have their advantages. MySQLite has both procedural and OOP API, while PDO is full OOP. On the other hand, PDO supports many drivers, including MySQL, and it supports named parameters, which we'll talk about in a bit. You can see the list of supported drivers of PDO in PHP's documentation, for which I'll leave the link in the description. So basically, PDO abstracts away the data access layer and provides the common interface. Do note that PDO does not provide database abstraction. That is something that some frameworks provide. PDO is like a data access layer. The first thing that we need to do is ensure that the specific PDO driver is enabled. While PDO is enabled by default with PHP, you might need to enable the specific driver for your database that you'll be using. We're going to be using MySQL driver, so we need to check if it's enabled, and if it's not enabled, we need to enable it. We can easily check that by simply adding PHP info in here, and then refresh the page and search for PDO. Within here, we see that the only driver available for PDO is the SQLite. So we need to fix that and enable MySQL driver. This process can be a bit different depending on what OS you are on or how your PHP is installed. If you've been following this series, then you should be on Docker. If you're not on Docker and you're using something like XAMPP, then enabling MySQL driver will be a bit simpler. You can open the PHP configuration file and uncomment the PDO MySQL extension. And after you uncomment it, you need to restart your web server and then check the PHP info again, and it should have the MySQL driver enabled. For Docker though, we need to install the PDO and enable it. Luckily, PHP repository in Docker Hub has a helper script that we could use to do this. So we can switch to the Docker file, and here we can simply run docker php ext install PDO and then space PDO_MySQL. And this will install the PDO and enable the MySQL driver. So now we need to run the docker compose up-d-build to rebuild the images. After it has finished installing, let's refresh the page now, and sure enough, within the PDO drivers, we see that now we have MySQL driver enabled. Now that we have the PDO all set up, we need to actually use it and connect to our database from PHP. So we can switch to the home controller for now, and I'm going to do all this within this controller, and then later we'll extract it somewhere else. So I'll get rid of this, and we can use the PDO class for this. So let's create a new object of PDO, and let's import that. And within the constructor, we need to provide the data source name, or in short DSN, as well as the database credentials and some options if needed. DSN is what contains the host of the database and the database name. So we can put in MySQL host equals localhost, and I'm going to hard code this for now, and later we'll extract it away. And then DB name, which is the database, will be MyDB, because that's the database that I created in the last lesson. Then the username will be root, and password is also root. Let me make this a little bigger here, and let's var dump db. Now let's refresh the page, and we're getting a PDO exception. If there are connection errors, PDO will throw a PDO exception, which is what's happening here. But why are we not able to connect to our localhost database? The problem is the host name. Notice that I put in localhost here. Let's change that to 127.0.0.1, and let's see if that works. I'm going to refresh the page, and now we're getting connection refused error. So we're still not able to connect. So what's happening is that PDO is trying to connect to this host within the app container, but there is no MySQL installed within the app container that runs on the localhost. We have a separate container for the database, and the name of that container is db. If I open the docker compose file here, we see right here that we have the PHP running within the app container, and this app container does not have any MySQL installed in it. The MySQL is running within the db container right here, and this is what exposes the port 3306. So instead of the localhost or this IP address here, we need to put in our container name, which is db in this case, and this should work. If I refresh the page, now we're getting the object and we're no longer getting any exceptions. Let's trigger the exception again, because there is a big problem that I want to point out. I'm going to provide the wrong credentials here so that we could trigger the exception, and let's refresh the page, and sure enough, we get this exception. But notice that within this exception, we're actually exposing the connection details, details. We have the full DSN here, and we also have the password, which is not secure, and it's actually pretty bad. And even if we were not displaying errors to the user and instead we were logging it to a log file or maybe sending it to a third-party service that were handling our errors, it's still sensitive information that is being exposed. To fix this, we can simply wrap this around the try catch block here. So we'll add try and then catch the PDO exception, and we could either throw our own custom exception or we can simply throw a new PDO exception with less information. So we would just get the message and the code and refresh the page, and those connection details are now gone from the message. So let's change this back to the valid password, refresh the page, and connection is back. Note that the connection will remain active until the script ends or there are no more references to the PDO object. We could also pass list of options as an argument to the PDO class, or we could use the set attribute method on the PDO object to set some of those attributes, but we'll be using the constructor argument for now. One of the options that you might want to set depending on your PHP version is the error mode, which determines how errors are handled by PDO. It controls whether you should throw an exception on errors, throw warnings, or not do anything at all, and simply let the developer inspect the error code and message through the available methods. Prior to PHP 8, silent mode was the default one, and if you wanted to throw exceptions on errors, you would have to set the exception mode through the options. But since PHP 8, exception mode is default one, so we don't need to set it here because I am on PHP 8. So let's actually run some queries. As you remember, in the last lesson we created two tables, invoices and users. I have populated the users table with some fake data in it, so we're going to query this table. To run simple queries, we can use the query method on the PDO object. So we can do statement equals db query, and then we can provide the query within here. So we can simply accept the query as the variable. So we'll create the query variable here and say select all from users. And this method returns an object of PDO statement class, which can be used to retrieve the results. So we could run fetch all, for example, and let's var dump statement fetch all, and let's see if we get the users. Let's refresh the page, and sure enough, we get users from the table. We could actually iterate over this directly. So we can take this and let's get rid of this and do for each db query as user. And then let's simply echo out some pre-tags here and do var dump user and then echo the pre-tag again. Let's refresh the page, and sure enough, it prints all the users. As you notice, the returned row is an array, which is indexed by both the column name and the zero indexed column number. And that is the default fetch mode, which is called fetch underscore both. We could change the default fetch mode globally within the PDO options, or we could pass the fetch mode as an argument to one of the fetch methods like fetch all, for example. We could also pass the fetch mode to the query method here as the second argument, but we'll use the fetch all for now. And let's set the fetch mode to be fetch object, which will fetch each row as an object of PHP standard class. Let's refresh the page, and sure enough, we get each row as an object. If you wanted the default fetch to be the object as well, you could set the default fetch mode within the PDO options here. So we could say PDO attribute default fetch mode and set this to fetch object, and we can get rid of this from here and refresh the page, and it's still fetching as objects. There are other fetch modes as well, and you can check the documentation for more details on them, but the most common ones that you will probably use are the fetch assoc, which will index the array by the column name, so each row is just an associative array with the column names being the keys. Another one is the fetch class, which will fetch rows as objects of the given class name that you can pass as another argument, and it will map the columns to the properties of the class by the name. And if the column name does not exist as the property on that class, then it will call the PHP's magic set method, which will dynamically create that property and make it available on the object. And fetch object, which we just did, fetches each row as PHP standard objects. So I'm going to remove the default fetch and revert it back to fetch as array. Using the query method is fine for simple queries like this, or even for complex queries that contain joins, order bys, where clause, and so on. But if you need to use users' input as parameters for the query, like within the where clause for example, then using query method is not ideal, and we'll see why in a minute. Also, if you wanted to run the same query within a loop, it would not be very efficient. That's where the prepared statements can help. Prepared statements is not a PDO or PHP thing. It's a feature that comes with database management systems. It has the following two major advantages. One is that you prepare a query once and then execute it multiple times with either the same or different parameters. This solves the problem of running the query method within the loop, for example. The second advantage is that it can help protect against SQL injections. SQL injection, simply put, is when a malicious SQL statements are injected into the query. That can happen through user input like query string or post data, for example, and so on. Let me show you an example. Let's say we wanted to find a user by email where the email was coming from a query string, for example. So it might look something like this. We have select all from users where email equals to quotes, and within the quotes we put email. And this email can be coming from query string, right? So we'll set email equal to the email from the get superglobal to extract the data from the query string. So we'll do get email, and let's test this out. Now within the URL, I'm going to add email and simply set foobar.com. Now we hit enter, and sure enough, nothing gets returned because we don't have any user with this email address. I'm going to echo the query here so that we can actually see what the query is. Let's add the break line here and let's refresh the page, and this is the query. Because we're injecting the user input directly into the query, we could technically modify this query, right? Let's pass in a double quote to kind of close off this double quote here, because this double quote gets closed off right here, right? So let's simply pass in a double quote after the email. So we could pass in foobar and then double quote and hit enter, and we're already breaking the application because we're getting the failure error, which is already pretty bad. Let's simply add the space using plus sign, and sure enough we get the space here. Now I'm going to add the logical OR operator, and sure enough we're getting that right in the query. So now we can actually break this query and have it return more users than what is expected by simply providing a truthy condition. And we can provide any condition, right? Because we're essentially injecting anything we want into the query. So we can add another plus sign here to add the space and simply say 1 equals 1, which will always be true, right? So let's hit enter, and look what our query looks like right now. So we're selecting all users where email is this or 1 equals 1. So this will essentially return all users from the users table. The only thing remaining to get this to work is to deal with this last double quote here. We could simply comment out everything else after our condition, and to do that we can use double dash. So let's add dash dash followed by another space and hit enter. And sure enough, now we're getting all of these users back and not just a single user. So this is the SQL injection basically. We're simply selecting all users where email is this or 1 equals 1, which always evaluates to true, and therefore whole condition is true. And then we're commenting out everything else afterwards. So even if the query had some additional conditions after, they would get ignored. There are many variations and many different ways of injecting SQL, and not all queries will look like this, but it is very simple to break an application if it's vulnerable to SQL injection. In addition to selecting restricted or unauthorized data, one can also delete data from tables, update them, and so on. So it is very important to not inject user provided input directly into the queries. So this is where prepared statements can help. So let's replace the query method with the prepare method and move it out of the loop and assign it to a variable. Prepare method also returns PDO statement object on which we can call the execute method to execute the query. And then we can use fetch all method on the statement to loop over the rows. So let's refresh the page, but we are still seeing all these users, which means that we're still vulnerable to SQL injection even though we have used prepared statements. So what is the problem? The problem is that prepared statements on its own will not protect you from SQL injection. We're injecting user input directly into the query right here. So whether you use prepared statements or not, you're still vulnerable to SQL injection. We need to either use the placeholders or named parameters, and I will explain the difference in a minute. Let's use the placeholders first. So we can get rid of this and simply put in a question mark here indicating a placeholder. And now within the execute method, we can pass in an array with the actual values. So we could simply pass in email here, and let's refresh the page. And sure enough, we don't see any more users and our query looks much better. Now let's change this from the select query to insert query. So we'll do insert into users, and we'll provide email, full name is active, and create it at date. And for values, we'll put the placeholders in there. So we'll put 4 placeholders, and for the last 2 we could hard code this to 1 and now, but for now we'll simply put the placeholders here and provide values for them. Next, we can get rid of this echo statement from here. We can also get rid of this var dump, and within the execute we need to pass in other variables as well. So we can pass in name is active and created at, and we need to create those variables. And I'm going to hard code these values for now, but in a real application these values could be coming from a post data, from form input, and so on. So I'll set name to John Doe, I'll set is active to 1, we'll format the date to the appropriate format, which should be YMD, hour, minute, and seconds, and we'll use this date. And for the email, I'll also hard code this to johndoe.com. Now the other thing I need to change is that we can no longer do this because this statement is not a select query, it's an insert query, so we cannot really fetch anything here. So we can get rid of this and put db query select all from users where id equals to id. And we don't have the id variable yet, but we can get the id by using the last insert id method on the PDO object. So we can do id equals db last insert id, and this method returns the ID of the last inserted row, and in this case this would be the ID of the last inserted user. Actually we could take this out of the loop because we're selecting a single user, so we could create a user object and simply fetch that row and then var dump the user. Now if we refresh the page, we see that user was successfully created and he gets the data of that user right away using this query. Now using placeholders here like this is fine, but when you have a lot of placeholders it can get harder to understand which value goes with which placeholder. Also, if we messed up the order and instead of putting email here we put email here, this would create some problems. If we refresh the page it will still work, but if you look at it, the email now is set to John Doe and full name is set to the actual email. This is because placeholders are positional, which means that order matters. Alternatively, instead of using placeholders like this, you could use named parameters, and named parameters are not positional and order does not matter. So instead of question marks here, we could simply replace them with colon followed by the parameter name. So we'll do email, name, active, date. And within the execute, now we need to provide an associative array. So we need to do name equals name, email equals email, active equals to is active, and date equals to date. Now this is going to cause errors because we have a unique index on the email and we're creating with the same email. So this would result in duplicate error. So if I refresh the page, sure enough we get the error, but this is a different error. It says that the argument number 2 must be of type int and string was given. If we look at the line 44 on home controller, that's right here. So let's var dump the get code here. So it's probably not returning as integer, that's probably why it's throwing an error. So let's refresh, and yeah, it's returning as a string, so we need to cast this to an integer like this and this should work. If I refresh, now we get the duplicate entry error. So let's change this email to something else so it does not trigger the error. So we'll do Jane Doe instead. Let's refresh the page, and sure enough user was created using named parameters. Alternative to passing parameters within the execute method here, we could actually bind them using the bindParam or bindValue methods. So we could remove the data from here and simply keep execute without any arguments, and before execute we can bind the parameters. We can call statement bindValue and we'll provide the name of the parameter and then the value of the parameter, which is name, and the third argument you can pass is the data type of the parameter, and by default it is PDO param string, which indicates that it's a string data type, and this is a string data type so we can just skip that. And the next one is email, so we'll set that to email, and the next one is active, and we could either do param int or param bool. In this case I'll do param bool. And finally we have the date, which is created at, and that is also a string, so we'll leave that the way it is. Now in addition to being able to specify the data types like this, another advantage of using bindValue and bindParam methods is that if you were working with loops and you were preparing a statement before the loop and you had few parameters that were same and you didn't need to bind them every time within the loop, you could bind them outside of the loop and then bind additional parameters within the loop and execute that statement multiple times within the loop instead of passing those values within the execute statement. Another method that I mentioned is bindParam. So let's change this bindValue to bindParam, for example, and the difference between the two is that bindParam binds by reference, meaning that if you change the value of the parameter that's bound, it will use the latest value before the execute. So even though we've bound this variable here, which is set to 1, if we change isActive to 0 here, and also let's change name to something like full bar, when we execute the statement, the name is not going to be changed because we're binding by value, but the isActive will be changed because we're binding by parameter. Another difference is that because this is by reference, you cannot assign direct values like this. So we cannot set something like 1 here. This is not going to work. But within the bindValue, you could hard code the data like this, and this would work. So we need to change that to isActive. And because we reset it to 0 here, once we execute this, the user will be created as inactive. So let's change this email to Joanne though. I know I'm not being very creative with the names right now, but it is what it is. Let's refresh the page. And as you can see, the isActive column is set to 0, even though we've set it to 1 here. So that's the difference between bindParam and bindValue. Note that you could use bindValue and bindParam with question mark placeholders as well. So instead of passing in the names here, if you had question marks here, right? If we removed all this and put question marks, then when binding the parameters, instead of using the named parameters, you would use the indexes of the placeholders. And indexes start from 1 in this case and not 0. So the name would be 2 because that is the second one. The email will be 1 because that's the first one in the list. The active would be third and date would be fourth. Let's get rid of this and let's change this to value also. And let's change email to simply J and refresh the page. And sure enough, it works as expected. Also note that within bindValue and bindParam, the param names need to be prefixed with a colon. So let me revert this back to using the named parameters. These parameters right here need to be prefixed with a colon because that's how they are set right here. However, it worked without the colon, right? And when we put them within the execute method, we also did not prefix them with a colon. The reason it worked is because PDO extension will add the colon automatically if it's missing, but you should not rely on this since the documentation does not mention that colon is optional, so you should just add the colons whenever you can. However, I think it is optional even though it is not mentioned in the documentation because I checked the source code of PHP PDO extension, and as you can see on the screen right here, it adds the colon whenever it's missing. I know this is a lot of information, but these are important stuff, so take your time and watch it multiple times if needed. I know it took me a while to grasp these concepts, so don't worry about it. Let's move on to the next topic, which is emulated prepares. You cannot use the same parameter name multiple times in prepared statements. For example, let's say that we had another date here called updated at, and we wanted to use the same date, so we would pass in the same date like this, right? Now I don't have this column, so I'm going to quickly add that column to our table. So I'm going to do alter table, add column, updated at, date time, default null. And we're missing the table name here, so let's add users. Let's run this, and we have the updated at with the default null. Now let's change email to something else. Let's refresh the page, and it worked. We have both created and updated at set to the same date and time. But how come it worked? I said that you're not able to use the same parameter multiple times. That is because PDO MySQL driver uses emulated prepares by default, but it can be disabled by using attribute emulate prepares option. Note that PDO will also emulate prepared statements and bound parameters for some drivers that do not natively support them. So because the prepares are emulated, you're able to get away with something like this where you're able to use the same parameter multiple times. However, let's disable the emulated prepares by using PDO attribute emulated prepares equals to false. Let's refresh the page, and we're getting invalid parameter number error, and that's because we're not able to reuse the same parameter names. So to fix this, we would either need to replace this with placeholders and pass in the same way, or simply change it to date 1 and date 2, or use created at and updated at and simply bind it multiple times. So we will do date 1 and date 2 here, refresh, and now the error is gone and we're getting the duplicate error because we have a user with this email. So let's change that, refresh, and it works. Also, there is something that you might have noticed here. Notice the ID now is coming back as an integer. Before it was coming as strings. Let me disable the prepares again. And let's comment out the insert statement for now. And I'm going to get rid of this as well. And instead of setting ID to the last insert ID, let's simply set it to 34, which is this right here. And let's refresh the page. So as you can see, when prepared statements are emulated, it is returning data back as strings. But when we disable the emulated prepares and we refresh the page, it is coming back as integers. And same goes for isActive, it's coming back as integer. And before it was coming back as string. So with emulated prepares disabled and using native prepared statements, you get few advantages in addition to possible performance boost. Integers and floats will be returned as integers and floats and not strings, for example. You will also be able to use placeholders in other clause statements like limit clause, for example. With emulated prepares, you won't be able to use the placeholder within the limit clause, but without emulated prepares, you could. So this is it for this video. In the next one, we'll continue with the PDO and talk about things like transactions, as well as how we can use the env or config files to get the database credentials. And also we'll see how we can extract and refactor this so that we don't have the database logic within controllers. We need to move this out of the controller and move it into something called models, which is part of the MVC. So thank you so much for watching. Please give my videos thumbs up if you enjoy them, comment, share, and subscribe, and I'll see you in the next video.